Are you recording? Yeah.
Okay, so this is talking about what I was trying to talk about on the board, and I'm sorry if it wasn't very organized. I just kind of wanted to give you some concrete examples before I actually just showed you this formula. But this right here, when we're talking about length or perimeter, we're just talking about first dimension. So that's when something's raised to a power of 1. Second dimension is your area. That's why we always have meters squared, inches squared, because that's your length times your width. And volume is always third dimension. That's always centimeters cubed or inches cubed. Those are raised to a power of 3. So the formula we're going to use is we're going to take the original measurement, whatever it is. We're going to take the scale factor. So like on my board, I had them doubling, tripling, and then I talked about the quadrupling. And then I'll take it to a power of 1 if I'm looking for perimeter. I'll take it to, and you can see it, it's just tiny. I'll take it to a power of 2 if I'm looking for area. And I'll take it to a power of 3 if I'm looking for volume. And then that will give me my new measurement. So a minute ago when I had that square, I'll just go ahead and do that concrete example. I had a square that was 1 on all sides. And let's just talk area. What's the area of this shape right here? 1. So my original measurement, my original area is 1. If I wanted to quadruple this, if I wanted to make it 4 times as big, 4 is what would go in the parentheses. That's how many times bigger I want to make it. Or it's what I want to shrink it by. It's not always make it bigger. It can be shrinking it by. And if I'm talking about what is going to be the new area of the new shape, would I take it to a power of 1, take it to a power of 2, or take it to a power of 3? Take it to a power of 2, and if I work that out, 4 squared is 16, and 16 times 1 is 16. And that would be my new area of my new shape, if I made it 4 times as big. So this is our formula here. Take the original measurement, whatever it is, and then whatever you want to do to it, if you want to make it twice the size, 4/5 the size, whatever, and then you take it to a power of 1 for perimeter, power of 2 for area, power of 3 for volume. Okay, so looking down here, I know these are tiny, so blow it up. Okay, Jim has plans to build a new barn. The area of the rectangular floor is 156 square feet. If the dimensions of the rectangle are tripled, what's the new area of the floor for the barn? Okay, so what is the original area that they gave us? 156. And what do we want to do to it? We want to change it how? We want to triple it, right? It says if the dimensions of the rectangle are tripled. So my change is 3. I want to triple it. I want to make it 3 times as big. Now, since I'm talking about area, is it a power of 1, a power of 2, or a power of 3? Power of 2. Work it out, and that'll give me my new area for my new figure. And what do you get if you work that out? 1404. And that would be the new area of the new shape. Oops, sorry, I can't see that. So I could do this where, well, I don't even know the dimensions. Like if I knew the dimensions of the shape, I could triple the sides and then I could recalculate the area. But this is without having to recalculate it. Okay, number 2 says Jim acquired new acreage on his farm. Instead of 10 square acres, the length and the width of his farm has quadrupled. How many square acres is he now farming? Okay, so how many square acres was he originally farming? 10. Instead of 10 square acres. So he originally had 10 square acres, and it says that they're doing what? Quadrupling. So what would I put in the parentheses? 4. So it's going to be 4 times as big. And what would my exponent be? 2, because I'm talking area. Okay, so what would the new answer be? 160. So now he would be farming 160 square acres. Have you guys done anything with this before?
No.
Change of dimension ever? No.
No.
When the tax test was the thing, this was something that always got covered from year to year, but we're not under the tax plan anymore. Okay, number 3. Jim bought new hogs for his farm. He wants to make a pigsty out of a corral that totals 24 feet of fencing. If Jim needs the pigsty to be 3/2 the size of the corral, how many total feet of fencing will he need? Okay, so how much feet of fencing did he start with?
24.
He started with 24 feet of fencing, so that's his original measurement. And then, what's my change? 3/2. I want the pigsty to be 3/2 the size. So 3/2. Do you know if we're talking about perimeter, area, or volume here?
Volume.
Perimeter. We're talking perimeter. When you talk about fencing, fencing goes around something. It's a distance around something. So this is going to be to a power of 1 because we're talking perimeter. What do you get if you work that out? 36. So his new corral will be 36 feet. Okay, number 4. Jim had a feed trough for his hogs. Are you liking all the farming things?
No.
Oh. The trough is a triangular prism and holds 64 feet of slop. Cubic feet of slop. Since Jim bought new hogs for his farm, he must increase the dimensions of the trough by 5/2 times in order to feed all his hogs. How many cubic feet will the new trough hold? Okay, so what's the original measurement?
64.
64. And what are we trying to do to it?
5/2.
Make it 5/2 times as big. What's this problem talking about? Volume. It wants to know about cubic feet, and that is volume. So what's my exponent? 3. Okay, work that out. If you need to see me put it in the calculator, I'd be happy to.
1,000.
Yeah, you get 1,000, and that would be 1,000 cubic feet. So that's how big his new trough is. Does anybody need to see me put it in the calculator? You do, Austin? Yep. Okay, so if I were to put it in my calculator, I would type it just the way I wrote it. I would type the 64 and then in parentheses 5 divided by 2 and then raise it to the third. So I just plug it in just the way I write it. Okay, let's flip the page. Okay, I don't know if I want to do all of these. I want to do some of them, and then I have 10 more that I want you to do on something else. Okay, let's start with number 2, and then I'm going to go back to number 1. Number 2 says, a parallelogram is dilated by a scale factor of 1/4 to produce a new parallelogram. Which of the following statements is true? Take a moment, read through them, and see if you can figure out which one it is. Let me draw a name.
No.
Cooper.
Can you re-ask the question?
Well, it's right here, number 2.
Oh, number 2.
Cooper. Such a disappointment sometimes. I'm moving on. Emily Gray. It is A.
I knew it.
Emily, you can come have a piece, Katie.
It's okay. I can't do that anyway.
If my pterodactyl screech, can I have a piece of candy?
No. If you pterodactyl speech, I'm probably going to hit you with one of Austin's crutches.
Nice, that's just as good.
Okay. In this problem, it said that it was going to dilate by a scale factor of 1/4. So that is the change. And then when it says, which of the following is true? So when A talks about area, area would have an exponent of 2. And if I work that out, I do get 1/16, which is what A is saying. Do you all know how, I mean, if you were using your calculator alone and you got 1/4 squared and you got that, do you know what to do to make that a fraction?
Move your decimal over 20.
There's this little button that says math. You go math, enter, enter. So when I hit math, it says fraction. Yeah. Enter. Yeah. Do it again. And there it is as a fraction.
So much easier on my calculator.
So if you ever, well, yeah, it depends. So if you ever get a decimal and you want to know what the fraction is, math, enter, enter. And that'll give you your fraction. So the 1/4 was the change, because I wanted to dilate it by a scale factor of 1/4. So that's the change. And then A is talking about area, so that's why my exponent was a 2. Okay, let's go to 4. 4 says, Jim is building a new doghouse for his Australian Shepherd, Rex. I used to have a dog named Rex.
Was he an Australian Shepherd?
No, he was a bird dog. The plans have dimensions of 6 by 10 by 10. What is the volume of the doghouse if Jim decides to triple the dimensions of the doghouse? Okay, so I need to know my original measurement. So if we're talking volume, do you know what the volume of the original shape would be? 600. 6 times 10 times 10. So the original shape has a volume of 600. And then what's the change in dimension I want to do to it? 3. I want to triple it. And do you know what the exponent is? 3, because we're talking volume. And take a second, work that out. I'm going to draw another name. I bought some new candy last night, so my candy bowl is quite exciting today. Good stuff.
Why don't you draw my name this time?
It's obviously me.
No,
What if I paid?
maybe.
If you want a credit card.
Savannah. D as in dog?
B.
Oh, B as in boy is correct. So when you work that out, you get 16,200. You can help yourself to that. Okay, let's hop down to number 6. Number 6 says, all of the dimensions of a pyramid are doubled to produce a new pyramid. Which of the following best describes the relationship of the volume of the new pyramid and the volume of the original pyramid? Okay, so we don't know what the original measurement is. We don't know that. But we do know the change. What's the change? The change in the dimension. What are they wanting to do to it? They're wanting to double it. So right here when it says that they want to double it, I'm going to put a 2 inside. Do you know what the exponent would be? 3. Because we're talking about volume. And what is that answer? Which of those do you think it would be? Anybody? D. The volume of the new pyramid will be 8 times the volume of the original. So the thing in parentheses is the change that's happening. It's doubling, it's tripling, it's quadrupling, it's 3/2 as big, it's 4/5 as big. This is for your perimeter when it's a 1, area if it's a 2, 3 if it's volume. Okay, now I want to kind of go backwards. So back to number 1. So number 1's a little bit funky. Number 1 says a square with an area of 36 square inches is reduced to a square with an area of 9 square inches. What is the scale factor? This time, I don't know the scale factor. I don't know the thing in parentheses this time. That's what I'm going to try to figure out. So I'm going to actually call that an X. But I do know the original area. What was the original area? 36. Do you know what the exponent would be? 2, because we're talking area. And then I actually know the new measurement. What's the new measurement?
That red thing comes back there.
9. So this one, I'm just kind of doing a little differently because I don't know the scale factor. I don't know if it's doubling, if it's tripling. I don't know what's happening. But I know the original measurement, I know the new measurement, and I know the exponents too because we're doing area. I need to solve this equation for x. Does anybody know what you would do first? If you wanted to get x by itself, do you know what you would do first? I have to divide by 36. So first thing I'm going to do is I'm going to divide both sides by 36. I actually want to keep this a fraction. And so I'm going to write it over here. What do you get if you reduce 9 over 36? Keep it as a fraction. 1/4. Okay, now Craig, how do I get rid of that squared? Now I'm going to square root both sides. And then you just think of it as each individual thing. What's the square root of 1? 1. What's the square root of 4? 2. So 1/2 is the change in dimension. That means that it's half the size. The shape is half the size of the original. And so it ends up being a 1/2. Okay. I want to see if you can do 5 on your own. And then I'm going to draw a stick. Take a moment. See if you can do 5 on your own. Are we ready? No.
We're waiting on her. She's slow.
Why are you waiting on Angelica? Why isn't Cooper doing Cooper's own problem?
Mark?
Mark! Seriously, what'd you get?
I'm just gonna say D.
It is D. Help yourself. Okay, so let's talk for a second. I know the original area, it says the original area is 2. So that's that guy. Do you know how many times bigger the new shape is? It's 5 times bigger because this length went from a 2 to a 10. So this shape is 5 times bigger. So that means that we have a 5 in the parentheses. Do you know what the exponent is? 2, because we're talking area. And if I work that out, you do get 50, which is answer choice D. So it's the original measurement times the change, and the change is that it's getting 5 times as big. The exponent's 2 because we're talking area, and you get 50. Okay, let's do another one for Candy. Let's try number 8. Candy makes everything so much more exciting. I'm going to try to eat Kit Kats. I bought some Kit Kats a while back, no offense, Craig, at Brookshire's, and they tasted so bad. I don't know how old they were, but they did not taste good. So I have decided not to buy candy from Brookshire's again.
Greg put something in your candy, so.
We still sport Austin,
Yeah.
Now,
like they're about to expire.
like the candy that's up at the cash register, that candy I've never had a problem with. But the candy that's like across from the deli meat stuff, I don't know how long that candy's been sitting there.
Doesn't say open.
What were you going to say, Adam?
You should call them.
Well, we'll see what my fingers do. Austin Mason.
Go with B.
See, that's a good idea.
Yes. D as in dog?
Yeah.
Nope. Adam?
Yeah.
I drew your stick.
For number 8, B.
Yes, it is B.
Yeah.
Okay. Let's talk about the original dimensions. The original dimensions, it's a rectangle, and it says they're 12 by 14. What's the perimeter of the original shape? If it's a rectangle with dimensions of 12 and 14, what's the perimeter of the original shape? 52. 12 plus 12 plus 14 plus 14. So 52 is the perimeter of the original shape. What's my change? What am I trying to do to it? Make it half the size. And because I'm talking perimeter, what's my exponent? 1. And if I work that out, I do get answer choice B. Adam, did you help yourself to the candy bowl?
Yes, ma'am.
Okay. Oh, we should do number 9 for fun. This is old time Algebra 1 here for a piece of candy. Take a second. And then I should probably give you your homework.
Going on number 9.
But your homework's like short.
Monday.
Oh, maybe.
Number 9 is so easy. I can do it in this.
Maybe I don't even want to give it.
Bam. Done.
Maybe I won't give it. Maybe we'll just do a couple more questions for Candy.
I got it, man. Right here. Call on me. And drizzle sizzle.
Masha!
Watch it.
It is A. You combine your 4x squared and your x squared, and that makes 5x squared. If you combine your 3x and 8x, that makes 11x, and then the 5 and negative 2 makes 3. All right. So I've changed my mind. We won't do homework. Let's try number 7 for Candy. Take a moment. Try number 7, and I'll call on somebody. I love that song.
Can I
Keep
go
singing to
over
me,
my
Mr.
tone?
McClung.
He sings beautifully. That voice makes me want to cry tears of angels.
I can. I showed you one time, right? Ding, 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 ding. All of you.
Chance the ukulele already.
Saying. Are we ready? Or am I rushing you? Okay.
No.
Are we ready now?
Right here, ma'am. And drizzle sizzle.
Christian.
Christian, it's definitely not A.
Go. Gavin.
Not A.
Hey.
With C? Okay. It is C. Now, I don't want you guys guessing. When it says that the diameter is 10, how do you find area of a circle anyway? Pi r squared. If the diameter is 10, what's the radius? 5, and that makes 25 pi. Okay, there's only one left on here. So let's try number 3, and then I will draw a name.
Is that what you're saying? What do you say? Wasn't making the real better.
Number 3. Number 3 is the only one left. If you've been paying attention,
No, he hasn't.
young man.
Tommy, you should probably do this.
Tommy! What is it?
Definitely not R.
C as in meow? Nope. Andrew!
Yay, I probably got it wrong. D.
As in dog?
No, as in that Miss Wood is so awesome.
Get some candy. That is correct. This one is different than the others. This really isn't talking about change of dimension at all. It wants the ratio of the surface area of the new cube to the surface area of the... wait a minute.
Yes, you do. I read one.
Wait a minute. Wait a minute. Wait a minute. I don't agree now. I have to give it to my meow. Okay, it wants the ratio of the surface area of the new cube. What's the new cube's surface area? 9 to the surface area of the original, and the surface area of the original is 36, and that reduces to 1/4. It should be C. I'm not going to take your candy away from you, Andrew, but Tommy, go ahead and help yourself. It should be C. Sorry about that.
I've already put it in my mouth. I've been kind of disgusting.
Well, I said I wasn't going to take it away. Tommy, you can have something there. Okay. All right. So no homework. And I'm still debating about what we're going to do on Monday. So I guess we'll figure it out when I see you on Monday. Well, I know it won't be a party, and I know it won't be a movie. What? Well, not on Monday. That would be like if I saw kids on Tuesday, but I wouldn't see you on Tuesday. What are you guys doing?
I think we're doing Tuesday, Wednesday.
Do you?
Only Wednesday.
On the Wednesday? Why?
Tuesday we go in the auditorium and then we get out at like 5th period.
Oh, sorry. Oh, yes. Yeah.
See, I just
Miss, do you have orange slices down there?
I do. Well,
Orange slices are so good, but I can't eat them.
well, I didn't buy them to eat them. I bought them because this is a regular octagon, and because the size is rectangles, it's a prism. We just have to pretend that this is an octagon too, because on Monday I was thinking about doing an activity with like real life shapes where we measure them and find the surface area.
I need it so I can get toothpaste out of my mouth so I can drink this. I'm on the deal on this one. Only like 3 people witnessed that.
Isn't it cool?
Yeah, I'll take those off the end when you're done using them.
Well, Mr. Malm saw them when he was under my desk earlier, and he's like, oh, those orange slices look so good.
A great
I
boy.
can't really eat
No one
them.
believes this, Mickey. Does it taste like cough syrup?
I think the grape's quite tasty. It's not my first choice or anything.
It's my first choice though.
Mine's blue raspberry.
Nice.
You're like, my God.
Can I have a Snickers?
How dare you try?
Thank you.
Can I have a Jolly Rancher, please? Huh?
Have a great weekend. What kind?
You too.
Oh, she just gave me hers. She didn't want one. I guess she didn't want it. She just gave me hers.
I was taking requests. Is that good for you? Oh, God.